This is part 3 of the lesson on negative exponents. So the first question here says simplify each of the following. Write your final answer with positive exponents. So simplify means we want to use our exponent laws to try to simplify our terms so that we only have a single x or a single a or b or c. And then we want to make sure that our final answer has positive exponents. So I'm just going to zoom in a little bit here. I'm going to start with the first question that says 2x to the 4 divided by x to the 5 to the power of negative 3. Now, I'm not going to deal with the fact that I have negative exponents until my very last step. That will always be the last thing that I do. So what I will do instead is I will try to use exponent laws to simplify as much as possible. And we know that we are supposed to follow order of operations or BEDMAS when we're doing our calculations or our simplification. So I do start with brackets. So everything in that bracket is what I'm going to do first. So I have 2x to the 4 divided by x to the 5. Now the rule for division is that if the base is the same, we leave the base alone and we subtract our exponents. So if I have 2x to the 4 divided by x to the 5, I still have that 2. And then x to the 4 divided by x to the 5, I subtract my exponents, and 4 take away 5 is negative 1. And that is still to the power of negative 3. Okay, next on our list, we're going to do our exponents. So that's this exponent out here. I'm going to apply this exponent to everything inside the bracket, and we do that by multiplying. So we do negative 3 times negative 1, and we will also do negative 3 times 2's secret exponent, which is a power of 1. So this is going to give me 2 to the power of 1 times negative 3 is negative 3, and then x to the power of negative 1 times negative 3, which is positive 3. Now to simplify this and write it as something with positive exponents, what we're going to do is leave the ones that have positive exponents in the numerator. And we learned that negative exponents make fractions. They have a flipping over action. So what that 2 to the power of negative 3 is going to do is it will flip the 2 down into the denominator, and our exponent becomes a positive 3. Now, I always like to evaluate the numerical part if I can. So this is going to become x to the power of 3 divided by 2 to the power of 3, which is 8. So our final answer is x to the power of 3 divided by 8. Now if I take a look at the next example, I have 18a to the 5, b to the negative 2, c to the 7, divided by 12, a to the 7, b to the 3, c to the negative 2, all in brackets to the power of negative 3. So if I follow my order of operations, I need to start by simplifying what's in the bracket first, and then I'll work on the exponent on the outside second. So when I'm dividing, the rule is if the base is the same, you subtract your exponents. So I'm going to do the exponents first. I have a to the 5 divided by a to the 7. So that's going to give me a to the 5 take away 7, which is negative 2. I have b to the negative 2 divided by b to the negative 3. Now this one's a little bit trickier because I have a negative already. So negative 2 take away 3 is going to give me negative 5. And then c to the 7 divided by c to the negative 2 is going to give me c to the 7 minus negative 2. I think I'm actually going to write that down. 7 minus negative 2. 2 minuses in a row actually make a plus, so we're going to end up doing 7 plus 2, which gives me an answer of 9. Now up front, if I do 18 divided by 12, I end up with a decimal, and I really don't want a decimal here. So what I'm going to do is leave it as a fraction, but I'm going to try to reduce if I can. So 18 and 12 are both divisible by 6. So I'm going to divide 18 by 6, which gives me 3. And then 12 divided by 6, which gives me a 2. So now that I've simplified, I want to try to write this. Oh, I forgot about my negative 3. Okay, so we've worked out what's inside the bracket. So next we're going to apply our exponent of negative 3. And the way we do that is we multiply it into the exponents of everything on the inside. So I do negative 3 times 9, negative 3 times negative 5, negative 3 times negative 2, and I also multiply negative 3 by the secret exponent of 1 that's hiding on that 3 over 2. So this is going to give me 3 over 2 to the negative 3. Now you'll notice I put it in brackets because it applies to the 3 and the 2. If you wanted, you could have written 3 to the negative 3 and 2 to the negative 3, but I find that a little easier. This is going to become a to the negative 2 times negative 3 is 6. B to the power of negative 5 times negative 3, which is 15. And C to the power of 9 times negative 3, which is negative 27. Now, before I flip anything, I am going to work on this a little bit because it's a little bit more complicated than just having a 2 to the negative 3. It's actually a fraction. So what I'm going to do here is we learned that the negative exponent makes a fraction. It has a flipping over action. So I'm going to use the 3 over 2 and flip it over to make 2 over 3 to the power of 3. And that's still times a to the 6, b to the 15, c to the negative 27. And I am going to go one step further before I deal with the negative exponent here. Normally I would do them all at once, but because it was a fraction, I do it separately because it is a little bit more complicated. So this is going to be 2 to the power of 3, which is 8, and 3 to the power of 3, which is 27, a to the 6, b to the 15, c to the negative 27. So at this point, I will look at the variables. I see that I have a negative exponent on the c. So the rule was that everything with a positive exponent stays in the numerator, and the things with the negative exponents will flip down into the denominator. Now, I already have a denominator on my fraction, so I'm going to use that to start with. I have 8 over 27. The a to the 6 is going to stay on the top with the a. The b to the 15 is also going to stay on the top with the a. And the c to the negative 27 is going to be pushed down into the denominator. It flips over to give me c to the 27 in the denominator. All right, our next example, we have 2a squared b to the 3c all to the power of 3 times a to the negative 4, b to the 2, c to the negative 1, all to the power of negative 2, divided by a to the 8, b to the negative 6, c to the negative 2. So first thing you want to do, don't worry about the negatives, just use exponent laws. So the rules are we start with brackets, and if I look inside the brackets, there really isn't anything to do. And then the next step would be exponents. And I do notice that the brackets are there because I have an exponent of 3 here, and there's a set of brackets here for that exponent of negative 2 there. So I'm going to multiply that 3 into all of the exponents in the first bracket, and then the negative 2 into all of the exponents on the second bracket. Now, the c has a secret exponent of 1, as does the 2. So we're going to do 3 times 1, 3 times 3, 3 times 2, and 3 times 1 to get 2 to the power of 3, a to the power of 6, b to the power of 9, c to the power of 3. Now the second one, same idea, except they already all have an exponent there. So we multiply negative 2 into all 3 of those exponents, which is going to give me a to the power of positive 8, b to the power of negative 4, and c to the power of positive 2. And the denominator is still a to the 8, b to the negative 6, c to the negative 2. Before I do anything more, I think I will also work out what 2 to the power of 3 is. That's 8. So this is 8, a to the 6, b to the 9, c to the 3, times a to the 8, b to the negative 4, c to the 2, divided by a to the 8, b to the negative 6, c to the negative 2. Okay, so then we have our multiplication and division. I'm going to do the multiplication in the numerator first. So I have a coefficient of 8 here, and I don't have any coefficient here. So normally I would multiply them together. This has a secret 1. So 8 times 1 is just 8. And then the rule when we're multiplying is that we add the exponents. So a to the 6 times a to the 8, we get a to the 6 plus 8, which is 14. B to the 9 times b to the negative 4 is b to the 9 plus negative 4, which works out to be b to the power of 5. And then c to the 3 times c to the 2, we add them together. 3 plus 2 is also 5. Okay. Up next, we just have our division to do. So the coefficient in the denominator is that secret 1. 8 divided by 1 is 8. And then we do our exponent laws on all the variables. So the rule for dividing is that we subtract the exponents. So a to the power of 14 take away 8 is going to be 6. B to the power of 5 take away negative 6. So 5 minus negative 6 actually ends up being 5 plus 6, which is 11. And then c to the power of 5 take away negative 2, which ends up being 5 plus 2, which is 7. If you're having trouble with the integers, use your calculator. It'll help. Now, our last step would be to flip anything that was negative, but we don't actually have any negative exponents. So that's our final answer right there. All right, we have one more question. This one's pretty long. So I have 10 x to the 10, y to the 5, z to the 2, times 3x to the 2, y to the negative 2, z squared, divided by 45 x to the negative 3, y to the negative 10, z to the 2, all to the power of negative 3. So BEDMAS, order of operations, says we start inside the bracket. Now inside the bracket I have multiplication, I have division, but I also have an exponent. So I start with the exponent. And we're going to multiply that 2 into all of the exponents in that grouping. So I'm going to leave the 10 x to the 10, y to the 5, z to the 2 from the first bracket. And here we're going to multiply the 2 into the secret 1 on the z, the negative 2, the 2, and the secret 1 on the 3. So 3 to the power of 1 times 2 is 2. X to the power of 2 times 2 is 4. Y to the power of negative 2 times 2 is negative 4. And z to the power of 1 times 2 is 2. Oh, probably can't see that part. Let's just slide this over. There we go. Okay, now normally we would rewrite out the next step and I would figure out what 3 squared is, but I think because this is such a long expression, I am just going to calculate that that is 9 and overwrite it so that I don't have to write out more steps than I need. So our next step is going to be to multiply our numerators. I'm going to start with the coefficients and we just multiply those normally. So 10 times 9 is 90. And then when we multiply the variables, we add the exponents. So x to the 10 plus 4 is 14. Y to the 5 plus negative 4 is actually just 1. And z to the 2 plus 2 is 4. Writing this part out over and over again is a bit of a pain, but we'll do it. Divide. 90 divided by 45 is 2. And then when we divide the variables, we subtract the exponents. So x to the 14 divided by x to the negative 3, we subtract 14 minus negative 3, which actually ends up doing 14 plus 3, which is 17. Y to the 1 minus negative 10 is going to give me positive 11. And z to the 4 minus 2 is 2. And that's still to the power of negative 3. So we just keep using our exponent laws. The last thing I need to do here is take that negative 3 exponent and multiply it into our exponents inside the bracket. So into the 2, the 11, the 17, and the secret 1 on the 2. So this is going to give me 2 to the power of 1 times negative 3, which is 2 to the negative 3. x to the power of 17 times negative 3. Now I'm going to use my calculator to check 17 times 3, which is going to be